All right, guys, today we're going to go ahead and talk about tangent lines. So tangent line is a line that hits a circle at exactly one and only one point. That specific spot where it hits is called the point of tangency. If a line is tangent to a circle, then the line is perpendicular to the radius drawn to the point of tangency. So in this picture, line AB is tangent to circle O, and it's tangent at point P. And because of that, the theorem's saying that AB is perpendicular to OP. And when I see that upside down T, we remember that means perpendicular. And we know that perpendicular means 90 degrees. So what we're going to do is we're going to go ahead and find the following information, or the following things. ML, this line right here, and MN are tangent to circle O at each spot. So for example, there ML is tangent at L and MN is tangent at N. Find the value of the missing angle. So in a four-sided shape, which is what I have 1, 2, 3, 4 sides. The internal angles will all add together to be 360 degrees. So that means that here at angle L is 90 and at angle N it's 90 because it's telling me that they're tangent. So 90 plus 117 plus x is equal to 360. And when I add those guys together and then take 360 minus that, my angle to degree is 63 degrees. Number 2, ED is tangent to circle O. Find the value of x. So it's saying again, this line is tangent and it's tangent at point D. So we can go ahead and create that right angle. And I know with a triangle, the internal angles will all add to 180. So I have 90 plus 38 plus x is 180. I don't know why I wanted to write 90 again. So when I go ahead and add those and then subtract, my answer is 52 degrees. All right, next theorem. Maybe. If a line in a plane of a circle is perpendicular to the radius at its endpoints, then it is tangent to the circle. So this is going backwards. Before it was saying if it was tangent, it's perpendicular. Now it's saying if it's perpendicular, the line's tangent. So it's a reversal. So because I see this right angle mark right here at point P, it's saying that AB must be tangent. So on numbers 3 and 4, we're asked to determine whether or not we are tangent at the specific point. So we're trying to figure out if ML would be tangent there. And I see I have a triangle created. Well, with tangency, it creates a 90-degree angle. And with 90-degree angles and a triangle, we have some theorems, Pythagorean's theorem. And we're going to use that to prove or disprove whether or not this this line is perpendicular. So my A and my B are the two sides that create the right angle. So it doesn't matter which one I do first. So I typically just pick whichever. So 7 squared plus 24 squared, is that equal to 25 squared? 7 squared is 49. 24 squared is 576. Well, what's 25? What's 49 plus 576? That gives me 625. And if I notice, 25 squared is 625. So because that statement is true, I can say that line ML is tangent. We're going to use that same logic to try and answer problem 4. So it gives me the following measurements, and it wants me to determine if line ML again is going to be tangent or not. So we're going to go ahead and put in that right angle mark to see if we could use Pythagorean theorem. That's where it's wanting to show whether or not it'd be tangent. So 4 squared plus 7 squared, is that equal to 8 squared? So I have 16 plus 49. 16 plus 49 gives me 65. However, 8 squared is 64. So even though we're one away, that's not a true statement and they are not equal. So because that falls through, it is not tangent. Okay, last kind of idea. Two segments that are tangent to the same point from a circle are congruent. So AB is tangent to circle O at point A, and CB is tangent to circle O at point C. Since they both go to that same point, they have to be the same distance away, so they have to be equal. All right, number 5. Circle O is inscribed, meaning it's inside triangle ABC. Find the perimeter of triangle ABC. Well, I'm missing some pieces in order to determine the perimeter, but we're going to use our knowledge of that theorem above to see what we can come up with. If you notice, AD and AF both go to line A, or to point A. So because of that, based on that theorem, they are equal. So AF is 10 centimeters. Likewise, DB and EB go to the same point, and they're both tangent. So they are also the same. They're also equal, so they're both 15. And lastly, FC and EC go to the same spot, so they're both 8 centimeters. So 10 and 10 gives me 20, 15 and 15 gives me 30, and 8 and 8 gives me 16. So 20 plus 30 is 50, plus 16 more gives me 66. And it's got a unit of measurement, and since it's perimeter, we're just walking around the outside, so it's one dimension. So my perimeter is 66 centimeters. Number 6. Circle O is inscribed, which means it's inside triangle PQR. Triangle PQR has a perimeter of 88 centimeters. Find QY. Alrighty. Well, start with the same logic we did before. If XP and ZP go to the same spot, they have to be equal, so this has to be 15. If ZR and YR go to the same spot, they have to be equal, so this has to be 17. And then I see that YQ and XQ go to the exact same spot, so they also have to be equal. However, oops, I need a different color. They're not equal to 17. However, I don't know what their distance is, and I don't want to necessarily call it X because if you notice, I already have an X in the problem. Oh, and I've got a Y and Z, and let's go with T. Could I pick any other letter? Yes. T is just the first thing that came to my head. So I already have the perimeter, so it's telling me I should set it equal to 88, since that's going to be my final answer. And I know that 15 plus 15 gives me 30, and 17 plus 17 gives me 34, and T plus T gives me 2T. 30 and 34 give me 64. And if I take 88 minus 64, I should get 24. And since they're both the same length, I can divide by 2 because they're equal. So it is 12 centimeters long. All right, let's go ahead and go get our theorem books now. All right, so the top part. And the bottom part. Oops, my finger's on part of it. Again, I just picked 2 problems. You can pick whichever 2 you want.